In Python, a comment starts with the hashtag character and ends the line that the comment is on. Right. So here we've got a comment, some text. Right. So that comment ends immediately ends this line. Right. So in other words, the Python interpreter ignores everything on this line with the hashtag. Right. Similarly here. Right. And here, the interpreter ignores everything after, well, starting with this hashtag and going to the end of the line. So that code there actually runs. All of this is ignored. Instead of using a hashtag, Java uses the double forward slash for a line ending comment. Right? So double slash, so that entire line is ignored. Same with this one. Right? Here, the double slash appears after some code, so it's this part of the line that's ignored. This part of the line is considered to be is considered as code. Java has a second style of comment. The comment starts with /*, and then the comment ends at the very next */. Right? And so this is Java's. So the comment can span multiple lines. This is sometimes useful. Well, it's useful if you have a very long comment. Sometimes it's useful for commenting out large blocks of code. So here we've got a comment starts with /*. The comment ends here at the next */. You can insert this style of comment anywhere you want. So here I can put in a /* and a */. Java ignores, or the compiler ignores, everything in red. Right? And so you can insert a comment into the middle of a line of code. Right? So this line of code here is double final value is assigned the value, all of this. Right? Or sorry, all of this, because there's another comment over here. Right? And so this is sometimes useful. If you need to, if you, for some reason, you want to insert a comment into the middle of a line of code, sorry. You'll notice that in this example, right, Python uses, here the Python code, we have the double star operator, which is the exponentiation operator in Python. There is no exponentiation operator in Java. Right? If I want to compute something raised to the power of something else, you have to use this method called math.pow. Right? So to compute 1 plus r raised to the power 10, it's math.pow 1 plus r, comma, 10. So Java has no built-in exponentiation operator. Some common types in Python and their literals are shown in the slide here. So the type corresponding to true-false values in Python is called bool. And so the bool literals are capital T true and capital F false. In Python, if you write down a number without a decimal point, it's what's called an int. If you write down a number with a decimal point, it's a float. Strings, right, are anything in between single, double, or triple quotes. And then you know that Python has a list type, and you can create a list using the square brackets. The corresponding types in Java are shown here. So in Java, bool is Boolean. Right? So the true-false values are little t true and little f false. The integer type, so if you write down a number without a decimal point in it, then that's an int. If you write down a number with a decimal point, that's a double, not a float. Strings in Java, double quoted. And then there is a list type, but we'll talk more about lists later on. They're quite different. Well, they appear to be. The way you use them is different in Java than how you use them in Python. All right, so in Python, everything is what's called a reference type. Right? So that means a variable stores, what the value that a variable stores is what's called a reference to an object. Right, so let me back up to the Python slide here. So when you write something like x gets the value 1, right? So what happens here is that there's a variable called x, right? If you look at the value that's associated with x, right, and that value is not the number 1 in Python, right? So instead what happens in Python is there's some object in memory that represents the int value 1, right? And this variable x, it stores what's called a reference to the object. So a reference is just some way, or is something that allows, in this case, the Python interpreter, to find the object whose value is corresponding to the value 1 in memory somewhere, right? So x doesn't store the value 1, right? It stores some information that lets it find the object whose value is 1, right? Similarly, y equals 1.0, y does not store the value 1.0, right? It actually stores some piece of information that lets it find the object whose value is 1.0. Java also has these reference types. So any type that begins with a capital letter, most programmers will assume is a reference type, right? So the type big S string is a reference type. The type big L list is a reference type. The type big A array list is a reference type. So back on the Java slide, when we write string S gets the value of hello, right? Then what happens is the variable S, right, does not store the string hello, right? It stores some piece of information that takes you to an object that represents the string HELLO, right? So it doesn't store the object, the string object hello, right? It stores a reference to the object hello. Classes are just user-defined reference types, if you're wondering what a class is, right? And so it's Java's mechanism of creating new types, or it's one of Java's mechanisms for creating new types. And that's why when you make a class, you should always name the class with a capital letter, right? It indicates to other Java programmers that your type is in fact a reference type. Right? Now Java also has primitive types. So any type that begins with a lowercase letter is a primitive type, right? Unless you make a class and you name your class starting with a lowercase letter, right? Your class is a reference type, but now you're confusing things because other Java programmers are expecting types with lowercase letters to be primitive types. Right? So back here, x is the primitive type int. Right? Now primitive types actually store the value of the primitive type. Right? So here x really does store the value 1. Right? Why? Right? Its type is little d double, so it's a primitive type. So in this case, the variable y really does store the number 1.0. Right? S, reference type, right? Capital letter S. S does not store the string hello, right? Does not store the string object hello. It stores a reference to the string object hello. There are 8 primitive types in Java. They correspond to the numeric types and the true-false type. Right? So the integer types are byte, char, short, int, and long. Normally, you use int. For strings, you'll use char. The floating point types are float and double. Right? Now remember Python, its floating point type is called float. Python's float type, confusingly, corresponds to the double type in Java. So normally, usually when you need a floating point type in Java, you normally reach for double. Okay, so reference variables store references to objects. So we already talked about this, right? So all variables in Python store references. Primitive types actually store a primitive value, right? So here in Java, right, when you make a variable x, its type is int, then it really does have the value 1, right? Here when you make the variable y, it's primitive type, so it really does store the value 1.0. All of the primitive types occupy a defined and fixed amount of memory, right? The different primitive types occupy different amounts of memory, right? So what's the implication of this? Well, each primitive type can only represent a finite number of values, right? Because each primitive type uses a fixed amount of memory, right? So what does that mean? If I can only represent a finite number of values, right, then for the type int, for example, right, there's only a finite number of ints that I can represent in Java. So what does that mean? Well, there must be some smallest int value, and there must be some greatest int value. Right? Now that doesn't happen in Python. Right? So a Python int, there is no predefined smallest int value or greatest int value. Right? In Python, your only limitation is how much memory is available to you on your computer. Right? Okay, so int is the usual choice for routine calculations involving integer values. Right? If you need to know what is the most negative int value, you can get that information using the class big I integer. So the class big I integer is the class that stores information about the int primitive type. Right? It stores information like what's the most negative value, what is the largest positive value, right, or the most positive value, right? So that's in integer.max value. And you can see here they're roughly -2 and +2 billion. To write down if you write down an int literal, that's just any number written without a decimal point in it and not ending in capital letter L or the lowercase letter l. Right? If you write down a number that has no decimal point in it and it ends with an L, then that makes a long literal. It's a compile time error if you write down a literal and try to store it in an int variable, and that literal represents a value that's outside the range of int. Right? So for example, if you write down the number 3 followed by 9 zeros, right? So 3 billion, you can't store that in an int called x, right? If you try to do that, the compiler will complain. And so here are some examples of using int, right? So int, it has arithmetic, right? Just like Python. The rules are mostly the same. There are some exceptions. In particular, there's no exponentiation operator, and division also works differently in Java. When you write down a literal, you can use underscores if you're writing down a long literal to make it easier to read. You're not allowed to use an underscore at the beginning or the end of the literal. If you know what a binary, octal, or hexadecimal number is, Java has a way to write down literals of those types, but that's not relevant for our current purposes. So the rule in Java is if you try to do arithmetic with 2 int values, then the result is always another int value, even if you do something like division. Right? So if you do division with 2 int values, then you get what's called truncating division. Right? So in other words, you compute the quotient, and then you throw away the fractional part. Right? So for example, here we have x divided by y. So x is 1, y is 3. Right? What's 1 divided by 3? Well, it's 0.33333. Right? So throw away the 0.333 and you get 0. Right? Z divided by y, well, 13 divided by y, so that's 4 point something. Right? Get rid of the point something and you're left with 4. Right? It works the same way with negative values. So if you were to take negative z and divide it by y, that's negative 13 divided by 3. So that's negative 4 point something. Throw away the point something and you get negative 4. Right? So you get truncating division, right? Truncate means chop off everything after the decimal point. And of course, you can use parentheses to control the order of operations. right? So x plus y plus z is 1 plus 3 is 4, plus 13 is 17. 17 divided by 3 is 5 point something. Throw away the point something to get 5. Okay, so if a calculation involving or arithmetic with two int values always produces an int value, what happens if you perform a calculation and you go past the range that an int can represent? So if I start at max value, what happens if I add 1? Right? Well, I can't represent x plus 1. Right? Well, I can't represent the mathematical value x plus 1. Right? Because that doesn't fit inside the range of int, right? That's the largest int that you can store. Right? So I can't actually store that value. So what happens is that when you compute x plus 1, the value wraps around back to the other end of the range. Right? So starting at max value, if I add 1, right, that wraps around all the way to integer min value. Right? If I start with x, so the largest maximum value, and add 2, right, that wraps around, right? So adding 1 wraps around to integer min value, right? And then I add 1 more for plus 2, right? And that becomes integer min value plus 1, right? X plus 3. So we start at max value, add 1 to get to integer max value, add 2, right? Add another 1, sorry, to get to min value plus 1, and then add 1 more to get to min value plus 2. The same thing happens if you do a calculation and the calculation wraps around on the negative end. Right? So if we start at min value and we subtract 1, that causes wraparound to integer max value. Right? If I start at x and subtract 2, right? Subtract 1, so that wraps around to max value, and subtract 1 more, so that's max value minus 1. X minus 3, so start at min value, subtract 1 to max value, subtract 1 more, and then subtract 1 more. So that's integer max value minus 2. Right? And so the way to think about this is that the type int represents what's called a cyclic range of values. Right? When you get to the far end, either one of the far ends, you just keep on going, wrapping around to the other end. Right? So integer overflow occurs when an arithmetic calculation with an integer type results in a value that is outside the range that can be represented by the type. Right? So in Java, wrapping occurs, but different results occur in other programming languages. So for example, in Python, wrapping never occurs because there is no built-in largest or smallest value in Python for ints. Right? Some other languages might indicate that an error occurs when overflow happens. Right? But in Java, the calculation succeeds. The result of the calculation may not be what you want. Right? So integer overflow has been one of the causes of many infamous events. Right? Ariane 5, that's the European Space Agency current generation of rocket, I believe. Its maiden flight resulted in a crash, in part caused by integer overflow in its programming. Deep Impact is a NASA satellite that was sent to crash to a satellite. NASA ended up losing contact with that satellite. Again, one of the underlying causes was because of integer overflow. And you can read about the other infamous occurrences of integer overflow by following these links here. If you're performing a calculation with a floating point value, then normally you want to use double, right? So not float. Float is the Python type. Double is the corresponding Java type. Like int, there is a class that contains information about the primitive type double. So that class is called capital D double. Right? So that class here contains information and methods on that work with little d double types. So the value, the constant max value, is the largest non-infinite double value. Right? So that's very large. roughly 10 to the power 308. Now, the most negative non-infinite value is just the negative of max value, right? So negative double max value is the largest negative double value. Min value for double is the smallest positive value, right? So the smallest value greater than 0. If you write down a number in Java and it has a decimal point in it, then the compiler considers that to be a double literal, right? If you end the number with an F, capital F or lowercase f, then that becomes a float literal, right? So in Java, double, the float is you can consider it to be the floating point type that represents a smaller range of values than double. Like with the int type, it's a compile time error if the numeric value is outside the range that a double value can represent. Right, so there is an example of some double literals, sorry. You can use underscores in a double literal as well. You can also use what's called scientific notation. So if you haven't seen this before, you can write down a number, possibly containing a decimal. It doesn't have to. Right, so you write down some number, and then the letter E, and then some integer value. Right, so that E means times 10, and then that's the integer exponent. So this is 1.000000099 times 10 to the power 6. Right, so this is common in scientific and engineering applications. Like int, any arithmetic operation involving two double values always produces a double value. Right? So here I've got x and y, so 3 and 13, but this time they're double values, right? They're not int values. Right? So 3 and 13, if I divide, if I compute, sorry, x and y. So 1 and 13, sorry, 1 and 3, 1 and 3, as double values. So if I compute that quotient, I get 0.333 and so on. Right? Again, you can use parentheses to be explicit about the order of operations. Okay, so if I perform some calculation involving doubles and the result exceeds the range of double, then you don't get overflow. Instead, you get what's called saturation. Right? So values saturate at this value called positive infinity and negative infinity. Right? So if I take two very large positive double values, right? If I multiply that together, I should get 10 to the power 400, right? Which is bigger than the largest, which is bigger than double dot max value, right? So instead of wrapping around, we end up with double dot positive infinity, right? If I compute negative 10 to the 200 times 10 to the 200, that's negative 10 to the 400, right? That's less than the largest, the most negative double value. So that becomes double dot negative infinity. Right? Similarly, if you take a non-zero number and divide it by 0, you get either positive or negative infinity. All right, so Python has user-defined functions. Right? So a function is just a procedure that you can call to perform a specific task. Right? So for example, I can write a Python function to find the max of two integer values, a and b. Right? Now I'm going to do this in a very funny way. Right? So I claim if I add a and b together, and then add the absolute value of their difference, right? My claim is that's twice the larger of a or b. Right? So to get the maximum value, I can just take that and divide it by 2. Now notice that's a very strange way to compute the maximum value of two ints. Right? Normally you would just use an if statement. Right? But here I'm doing this. There is a reason for doing this. We'll come back to this in a later lecture. Okay, so if I put this max2 function somewhere, in a module somewhere, and then from a separate module, I would like to call max2, right? And then what you would do in Python is you would import the module containing max2, right? And then you can call max2 just by writing down its name, round bracket, passing in two integer values, right? And in this case, max2 returns a value, right? But there's nothing on the first line where we declare the function that indicates max2 actually returns a value. Java has no functions, right? Because everything in Java belongs inside of a class. So here, right, max2, it's not defined inside any sort of Python structure, right? Here, the corresponding max2 method must belong inside some class, right? So here it's inside the class lecture2, right? But you can't have a Java method that's outside of a class, right? And so Java doesn't call functions. It calls them methods, right? And so the closest analog in Java to a Python function is what's called a public static method. Right? Methods are similar to functions. They must be defined inside of a class or something called an interface. So here's the max2 method, right? Inside my class lecture2, right? Notice that the declaration of the method is quite different than in Python. To call the max method, a method in another class that's also inside of a different what's called package must import the lecture2 class and then call the max2 method using the syntax class name. So that's the class name that max2 is defined in. Right? So lecture2.max2 and then pass in the two arguments. So here I've got a new class called test lecture2. It's defined in a separate package compared to lecture2. We'll talk more about packages a little bit later on in the course. So if lecture2 is in a different package than test lecture2, then we import the lecture2 class from that package, and now we can call the lecture2 method max2. So when we call the lecture2 method max2, we use the name of the class, followed by a period, followed by the name of the method, and then the arguments to the method.